Hello students, this is the help video for the Units 4 through 5 exam for Chemistry, SCI102B. So let's go ahead and take a look at question number 1. Question number 1 is pretty simple. Remember that we talked about chemical equations and how reactants are what you start with and products on the other hand are what you end with. So if we're taking a look at a reaction, you will see generally the reactants are on the left-hand side of the arrow. The starting side of the arrow. So in this case, ammonia and hydrochloric acid are what we are starting with, our reactants. Whereas over here we have our products. Products are what we end with. Those will be on the right-hand side, in this case, ammonium chloride. So for question number 1, you should be able to pretty easily identify what things are on the starting side. Those will be the reactants. What things are on the product side. On the ending side, that will be the products. Go ahead, pause the video, and continue playing when you're ready. Question number 2 is asking a little bit about what's happening during exothermic and endothermic reactions. Remember that in an exothermic reaction, the heat is actually exiting. That's what that prefix exo means, right? Heat exits. And in this case, if heat is exiting, meaning it's being released or leaving, the reaction, then in that case you're going to end up with something that ends up feeling really hot. All right, so exothermic reactions feel hot. Now what you can see here is that when we talk about exothermic reactions, the heat is actually a product. And that again should make sense. It's being produced, it's leaving, it's feeling hot. It is a result of this experiment. So you will see the product of heat on the right-hand side, on the product side if it is exothermic. On the other hand, if we're talking about an endothermic reaction, remember the endo means that heat enters into it, and endo means that heat is being absorbed. So in this case, we can see that heat is going into it, all right? Or in other words, it's like the reaction is stealing heat. Right, so it's stealing the heat, and in that case you end up feeling cold. So it ends up feeling much colder. It's stealing heat from its surroundings. So in this case, in order to have an endothermic reaction, the heat actually needs to be on the reactant side. So you can see here that this is something that we are starting with in this reaction, and so heat is going into it. It needs heat in order to occur, and so it's going to steal that heat, and as a result it will end up feeling much colder. All right, that should help you with question number 2. Go ahead and pause the video and continue playing when you're ready. Question number 3 is talking about what a chemical formula is. Remember that chemical formulas are used to abbreviate which elements are in a compound. So first off, you do need to know what each of these elements are. If for some reason you don't remember what they are, you can always go to www.ptable.com and you will see that, for example, H is hydrogen and O is oxygen. Now the subscripts, remember the small numbers at the bottom right after the abbreviation is going to be how many of that element there are, right? So you can see here there's a 2 right after this H telling us that there are 2 hydrogens in water, and you'll notice that after oxygen there is a blank, and remember that blanks don't mean 0, because if blanks meant 0 we just wouldn't put in the oxygen. Blanks actually mean 1. So in this case, because our oxygen has no subscript, it's just blank, that means that there is one of these molecules, one of these oxygens. All right, so that should help you here. Let's go ahead and take a look at an example. So for example, sulfur dioxide, remember that capital S is its own element. If we were to look at ptable.com, we would be able to see that that is sulfur. All right, so you should be able to know what that element is. And again, taking a look at its subscript, in this case, sulfur has no subscript, it's blank, and blanks mean 1. So in this case, there is 1 atom of sulfur here. And for O, remember if we were to look at ptable.com, we would know that that is oxygen, just a single capital O is oxygen. And taking a look at its subscript right after it, that is a 2, and that 2 means that there are 2 atoms of oxygen. So you should at this point be able to do question number 3. Please pause the video, continue playing when you're ready. All right, let's go ahead and take a look at question number 4. Question number 4 is how to balance an equation. I'm going to go ahead and do an example. This is not a formula that anybody has, so please do not copy this. All right, so again, do not copy. You will get the wrong answer if you try to copy this. All right, so let's go ahead and take a look here. If I had A, B, and C right here, and taking a look at A, B, and C right here, all right, so you should draw these out on your piece of paper. And then don't forget that we're going to go ahead and take a look. We'll just draw a line here. We'll go ahead and take a look at what we have on each side. So going over here, you can see in this case I have a 3 on my A, so that means I have 3 A's over here. I also have a B, which has a blank subscript, so that's just 1B. Because blanks mean 1. And then right here you can see I have a 2 on my C, and so that would be 2 C's right here. Oops. Here we go. All right, so that right there is what my first molecule on my reactant side looks like. Let's go ahead and take a look at this one. So over here I can see that I have a 6 next to my A, so that means I need 6 A's. 6. I'll just put them all together so they all fit. And then I also have on here B, which there are 2 B's right here that we can see, right? So we'll put 2 B's right there as well. Now let's go ahead and take a look here at our last one right here. Our last one right here is just a C by itself, and so I would write in here, put a C. Okay, just a single C. Remember, it has a blank here. Blanks in this case would mean 1. All right, so I'm going to go ahead and count up what I have on each side. So on the left-hand side, you can see I have 3 atoms of A, I have 1 atom of B, and 2 atoms of C. Over here on the right, I have 1, 2, 3, 4, 5, 6 atoms of A, 2 atoms of B, and 1 atom of C. All right, so taking a look here, first thing I need to balance are my A's, right? I have 3 on the left, 6 on the right. So I would take a look at which side needs more. So in this case, my left side needs more of the A's, and so I need to add more of a molecule that includes the element A. In this case, there's only 1 element on this side, so I'm going to go ahead and just add another one of those elements. All right, so taking a look here, go ahead and put this in right here. All right, so there we go. We have another one right there. And recounting here, now I can see that I have 1, 2, 3, 4, 5, 6 A's. I have 1, 2, 2 B's. And recounting my C's now, I have 1, 2, 3, 4, right? So I have 4 C's here. So taking a look here, now let's see what we have. So my A's are now balanced on each side, and my B's are balanced on each side. I just need to fix my C's. So taking a look at which side needs more, I have 4 on the left, 1 on the right for my C's, and so that means clearly my right side needs more C. So taking a look at which molecules I should add to add more C, I can't adding more A6B2 is not going to help me. It has no C in it. So I'm just going to go ahead and add more C here. All right, so I'm going to go ahead and add another C. So now I have 2 on the right. That's still not enough, so let's add another one. Now I have 3 on the right. Still not enough. Let's add another one. And now I have 4 on the right. All right, and that gives me enough. So I have enough atoms now on each side where the individual atoms are balanced. Now we just need to figure out the coefficients. Remember, coefficients are the big numbers that go in front, right? So let's go ahead and count them up. So to count up big coefficients, remember that big coefficients. So first we balance the individual tiny atoms, those are the letters on each side, and then we're going to go ahead and find the big coefficients, which are the same as the big circles. So we just need to go ahead and count up the number of big circles. Okay, so taking a look here in my example, you can see I have 1 big circle right here of A3BC2 and a second one right here. So my big number here should be a 2 in front. Over here, you can see I just have 1 big circle, so my big number in front would be a 1. And then over here, you can see I have 1, 2, 3, 4 big circles of C, so I would add a 4 in front. All right, so that should help you with question number 4. Again, you'll need to balance your own unique equation. Everybody has a different one. Please pause the video and continue playing when you're ready. All right, so taking a look here, the atomic mass with units AMU of an element on a periodic table is actually the same as the molar mass. So this is question number 5. Remember that we learned about this number at the bottom being our atomic mass in AMU. However, this is also our molar mass in grams per mole. Remember, if we're talking about AMUs, that's for a single atom, which you and I cannot see. But if you're talking about grams per mole, this is an amount of many atoms that we can actually see, because remember we learned that 1 mole is 6.02 times 10 to the 23rd atoms. So if that's 12 grams here per that many moles, that many atoms, then that's an amount of carbon that you can actually see. All right, so when we're taking a look at this question right here, molar mass of one of these mystery elements, again, you want to be looking at the numbers at the bottom. All right, make sure that you copy them exactly like how you see them in your diagram up here. And then don't forget, again, the correct units should actually not be AMUs because we're talking about molar mass. So our actual unit should be gram/mole. All right, so please make sure that your units for this are correct. Again, AMUs is not acceptable. It does need to be grams per mole, G/mol. No spaces for question number 5. Pause the video, continue playing when you're ready. All right, question number 6 is asking about how to calculate the molar mass of a compound. So everybody has a different compound, so obviously don't copy this example. Everyone has a different compound. All right, so what you're going to go ahead and do though is you're going to see how many of each of the atoms A, B, and C are in your compound, and then multiply it by the molar masses that you can see up here. Right, so you can see these molar masses are listed up here. Okay, so taking a look at an example here, so methane is CH4. So we're going to go ahead and take a look at this example. So taking a look at carbon, there's a blank after it. And so remember that blanks mean that there's just one. So there's one carbon in methane. And for hydrogen, you can see there's a 4 after it, so there are 4 hydrogens here. So in the same way, you should be able to determine based on subscripts how many A's, B's, and C's there are. Okay, then what we're going to go ahead and do is enter in the molar masses. So we know that the molar mass of carbon comes from the bottom number, which in this case is 12.011. All right, and we know the molar mass of hydrogen here is 1.008. 1.008. All right, so again, these molar masses you actually already have. So let me go ahead and show you what that looks like. All right, so you're going to be plugging in these molar masses. So this one needs to go in for A, this one right here needs to go in for B, and this one right here needs to go in for C. Okay, then we're going to go ahead and multiply those together. So you can see here that I've got 1 times 12.011, which just means one mole of carbon. So that's going to still be 12.011. Let's see if I can change that to a different color so it's easier to see. And then down here we have 4 moles of hydrogen times its 1.008. So if I were to grab a calculator here, right, so 4 times 1.008 would give me 4.032. Right, so over here I would write out 4.032. So that gives me the molar mass of a single hydrogen, the molar mass of a single of 4 moles of hydrogen. But now I need to go ahead and put it all together. So I'm going to go ahead and add these together. And if I were to add those together, so grabbing my calculator over here, so 12.011 plus 4.032 should give me 16.043, right? So my answer here would be 16.043, and units here would be grams per mole. All right. However, remember that yours is going to be a little bit different, right? So let's go ahead and take a look at yours, right? So again, you're going to multiply here the number of moles of A times its molar mass, 15.1. I can actually just go ahead and fill those in just to make our lives easier so that we can actually see that. And B, right, which is 17.2, and C, which is 19.3. All right, so that should give us some answers over here, right? So you have your molar mass of however many A's you have, however many B's, however many C's, and then just add them all together. All right, so you'll go ahead and add them all together. and that will give you your answer overall down here. Remember that in the first box is where your number goes. You should have 1 decimal place, right? So make sure you have 1 digit after the decimal. And then units here should be grams per mole, so G/mol, no spaces. All right, go ahead and pause the video and continue playing when you're ready. All right, so question number 7 is asking about mole ratios. So everybody has different chemicals that they are taking a look at the mole ratios in this example of ethane being combusted with oxygen to form carbon dioxide and water. So ethane, oxygen, carbon dioxide, and water. Everybody is looking for different mole ratios. I'm going to go ahead and show you an example though, not the actual question, right? So here's an example. What are the 2 possible mole ratios for fluorine and nitrogen trifluoride? Again, make sure that you do not copy my example because it's just an example. So let me write that here. Do not copy. Okay, so let's go ahead and take a look though at this example. So what we need to do is we want to take a look at the mole ratio of fluorine, again F2, and nitrogen trifluoride, NF3. And what we'll go ahead and do is we need to look at their coefficients, big numbers in front. That will give us the moles that are in the balanced chemical equation. So taking a look here for F2, the coefficient here is a 3, so we should have a big 3 next to moles of F2. And over here we can see that we've got NF3, and its big number in front is a number 2, and so that right here we'll go ahead and put in a number 2 right here for moles of NF3. Now remember that we can actually flip this because it just kind of depends on what you're solving for. In this instance, we're solving for what's on top, which would be moles of F2. However, we can actually flip that and instead solve for moles of NF3. Now the numbers still need to stay next to their correct units. So just like up here, we saw the 2 moles of NF3. It should again still be 2 moles of NF3. And then the 3 moles of F2 would now just be on the bottom. So again, that's just going to flip. And you can see that same flipping happening over here, right? So start off with your moles of your first chemical on top, over your moles of your second chemical on the bottom, and then just flip them, making sure that the numbers are still with the correct number of moles. So make sure you also flip the numbers. They should be with the correct units / chemical. Let's say chemical. All right, so that should help you out with question number 7. Pause the video, continue playing when you're ready. All right, question number 8 says, what are the 2 possible conversion ratios using molar mass of the chemical here? All right, so in this case, there's only one type of chemical, so everybody has a different chemical, and everybody has a different molar mass, so make sure again that you don't copy this one. But let's go ahead and take a look at an example. So in this case, I have the chemical NF3, and it has a molar mass of 71 grams per mole. So what I'm going to go ahead and do is take a look at what is next to grams. So remember, this is just a fraction in disguise. So next to grams is the number 71, so I would put 71 next to anywhere I see grams. And then over here, what is next to moles? That'll be on the other side. Remember that next to moles is a blank, and blanks just mean 1. Blanks mean 1. All right, so on the other side where it says moles, I would put 1 mole of NF3 and 1 mole of NF3. Again, you can see this idea of just flipping, making sure numbers stay next to the correct units. Okay, so again, just take a look at what number is next to grams up here. That should go next to grams here and on the bottom here. And then what number is next to moles? Again, it's a blank. Blanks should just mean 1. All right, go ahead, pause the video and continue playing when you're ready. All right, so question number 9 says, if you have blank moles of A, how many moles of B will be produced? All right, so let's go ahead and take a look here. We're going to start off with what we know. And in this case, what we know is this number right here. So you're going to go ahead and plug in this number right here. And the units here, everybody does need to have units. Units here are going to be MOL space A, moles of A. Okay. Then you're going to go ahead and figure out how many moles of B will be produced. So we want to get rid of moles of A, so that's going to go on the bottom. and what we're solving for goes on top. So in this case, we're solving for moles of B, so that's going to go on top. Okay, now in order to figure out where these numbers come from, remember conversion ratios always have to come from something that is always true, which in this case is our balanced chemical equation. So for moles of B, you should put whatever the coefficient of B is here. And then for moles of A, you should put whatever the coefficient for A is right here. Okay, then what you're going to go ahead and do is just fill in the numbers. So fill in what number you had here times what number you had on top here, and then down here what number you had 1 times blank on the bottom. Then you'll go ahead and actually solve that. So go ahead and separately, right, multiply the top and then multiply the bottom. And then don't forget that this is just division in disguise. So once you have the top and the bottom, you'll just do the top number divided by the bottom number. Remember, the top goes into the calculator first. Top number goes into the calculator first. All right, divided by the bottom, and that will give you your final answer. You do need units here, so let's take a look at our units. Remember that we actually got rid of moles of A, so your final units here should just be moles of B. All right, so right here, we're going to have moles of B as our final units. Don't forget your units, otherwise you will lose points. All right, go ahead and pause the video and continue playing when you're ready. Question number 10 is now asking for the moles, that is the number of grams of boron trifluoride. So again, we need to start off with what we know here. So right here, I do know the grams of boron trifluoride. So you're going to plug in that first number that you see. And again, units here should be G space BF3, boron trifluoride, exactly as you see it right here. Now we want to get rid of grams of boron trifluoride, so in the next step it needs to go on the bottom. And on the top is what we're solving for. So taking a look here, what am I solving for? Again, I'm actually solving for moles of the same chemical, right, which is still boron trifluoride. So that will go on top. So moles of BF3. Okay, now remember again, this number needs to actually come from something that's always true. All right, and so something that's always true here is going to be the molar mass of boron trifluoride. So that's going to come from up here. So whatever number is next to grams should go on the bottom, all right, which in this case would be 67.8. Sorry, 67.8 here. And whatever number is next to moles should go on the top here, which remember we have a blank. Blanks just mean 1. All right, so you should be able to now take the numbers, just multiply the numbers. You don't need units in the second part. So whatever number you have here times 1 on the top, and down here 1 times whatever number you have on the bottom, 67.8, right? And then go ahead and solve that, right? So you should be able to solve what do you get on the top and what do you get on the bottom. And then don't forget, this is just division in disguise. So go ahead and do the top number divided by the bottom number. Again, top number goes first into the calculator, and that will give you your numerical answer. Don't forget that you do actually need units here. So taking a look at our units, we got rid of grams of boron trifluoride, right? So I should be left with moles of boron trifluoride. So right here, my final answer, units should be MOL space BF3, moles of boron trifluoride. Pause the video and continue playing when you're ready. All right, question number 11 is how many grams is blank moles of aluminum diboride? So we're going to go ahead and start off with what we know here, which is the number of moles of boron aluminum diboride. All right, so in this case, I would go ahead and fill in my units here, MOL space AlB2. Aluminum diboride. All right, and we're going to go ahead and this time we want to get rid of moles here. So moles AlB2 should go on the bottom, and on the top is what I'm solving for, which should be grams of AlB2, again, because we are solving for grams right here. Okay, so taking a look at that, we're going to go ahead and take a look at how do we get these numbers. Again, taking a look at how you get these numbers, they should come from something that's always true, which in this case is the molar mass of aluminum diboride. So whatever is next to grams should go on the top here, right? So in this case, this would be 48.6. And whatever is next to moles should go on the bottom. In this case, that's a blank, and blanks mean 1. All right, so now you should be able to multiply those numbers, right? So figure out what do you have on the top, what you start with times 48.6, on the bottom 1 times 1, and then solve for the top and solve for the bottom. And then don't forget that once you have solved for the top and the bottom, you should be able to do the top divided by the bottom, right? So do all of those steps separately. Solve for the top, solve for the bottom, then do top divided by the bottom. That will give you your final answer here. Don't forget you do need units for this part, so let's analyze our units. Taking a look here, we got rid of moles of AlBl2, and all I'm left with is grams of AlBl2. So our units here should be grams space AlB2 aluminum diboride. All right, pause the video, continue playing when you're ready. All right, feel free to continue working on questions number 12 through 19. However, because these are all things that you have seen before. However, if you do want more support, there will be a video uploaded for these as well on Thursday. And then don't forget that the exam will be zeroed out at the end of the school day on Thursday. So make sure early in the morning, make sure that you use that time to work on 12 through 19 if you do not do that today. Thanks so much, and we'll see you later.